Dear students, welcome to today's class. Today also I am going to explain very important problems which are theoretically sound problems from the chapter continuity of functions. Okay, so don't skip this video. So every problem you will learn one concept. Okay, now so let us start our class with the first problem. The first problem is, if f of x is equal to x plus 1 upon x minus 1, g of x is equal to 1 upon x minus 2, then discuss the continuity of the function f of x, g of x, f circle g of x, g circle f of x. Okay, now what is the continuity? Right here, f of x, g of x continuities we can easily say without using any pen and paper. The first one is f of x. What is f of x here? So here f of x is equal to x plus 1 upon x minus 1. Clearly the function is not defined at x is equal to 1. At x is equal to 1, the function is not defined. It is not defined. Why? Because here 1 plus 1 upon 1 minus 1. Here 1 minus 1 will become 0, denominator will become 0. When the denominator is at 0, then it is not a real number. Therefore, clearly f is discontinuous at x is equal to 1. So, remaining all places it is continuous, but it is x is equal to 1, it is discontinuous. Okay, because why? Because it is not defined at x is equal to 1. Very clear. Now coming to second one. What is the second one? F of x is g of x is equal to 1 upon x minus 2. Clearly at x is equal to 2, the function is not defined. Why? Because 2 minus 2 0, denominator 0. Therefore g is discontinuous at x is equal to 2. Otherwise you can say that g is continuous at x belongs to set of all real numbers except 2. Here also it is continuous at all real numbers except 1. Okay, now that is those two things everybody knows. Then we are going to see the f circle g of x. Now third one is f circle g of x. By definition, f circle g of x is equal to f of g of x, that is equal to f of g of x value is equal to how much? 1 upon x minus 2. Again f of 1 minus x minus 2 is substitute here, 1 by x minus 2 plus 1 by x minus 2 minus 2. Okay, now so this here x minus 2 gets cancelled. So here 1 plus x minus 2 by 1 minus 2x plus 4. Okay, now so this is also 1, this is also 1. So this is equal to 1 minus x plus 2. 1 minus x plus 2. So this is given by, so this is equal to x minus 1 upon 3 minus x. X minus 1 upon 3 minus x. Now here please concentrate on this step. So we got f circle g of x is equal to x minus 1 by g minus x. Okay, so everybody you have to be very careful while writing the answer here. F circle g of x is discontinuous, okay, at x is equal to 3. Why? 3 minus x, therefore it should not be equal to 0, therefore x should not be equal to 3. Therefore at x is equal to 3, 3 minus 1 by 3 minus 3, here denominator will become 0. Therefore f circle g is discontinuous at x is equal to 3. Is it your right answer? Is your right answer? In the options it will be given discontinuous at x is equal to 3. They will give like that. So if you write that x only at x is equal to 3, your answer is not correct, your answer is wrong. So only half correct. Half correct means half false. Then how to do this? Discuss here, see here 1 upon x minus 2. When x is equal to 2, what happens here? When x is equal to 2, what happens? Therefore, 1 by 2 minus 2, 1 by 0. It is not a real number. That's why what you have to write down? F of x is discontinuous at x is equal to 3, and g of x condition also you have to write down. What is that? And x is equal to 2. That you have to write down. Understand? So, are you catch this point from this from this? So, what is the point you have discussed? So, if you are finding f circle g of x, f of g of x you have to find out. In this g of x, g of x is discontinuous at where? 2, and f circle g also discontinuous at 2. Therefore, otherwise you can write down f circle g is continuous at set of real numbers except 3 comma 2, except 3 comma 2. Understand this? Similarly, you can do this problem g circle f of x. G circle f of x problem also you can do. Okay na? Okay na? So, while discussing this, so g circle f of x condition also you have to write down. F of x condition also you have to write down, where it is discontinuous. F is discontinuous at x is equal to 1, and g circle f where it is discontinuous. So, if I calculate the problem, take it as a homework. Okay na? So, from this what you have to write down? What you have to take the point here? G of x discontinuity also you have to mention here. Both. Okay na? I hope that you understand this problem. Okay. So, let us go for next problem. Welcome to second problem. Find the value of f of 0. Find the value of f of 0 so that the function f of x is equal to under square root of 1 plus x minus cube root of 1 plus x upon x becomes continuous at x is equal to 0. So, first of all, he is given one important point. It is continuous at x is equal to 0. So, whenever it is saying that continuous at x is equal to 0, we have limit extends to 0, f of x is equal to f of 0. Limit extends to 0, f of x is equal to f of 0. Then we say the function is continuous, no breaks at x is equal to 0. Understand this? Now, that means to find f of 0, it is enough to find limit extends to 0, f of x. Now, find the limit extends to 0, f of x. Limit extends to 0, right? Root of 1 plus x minus cube root of 1 plus x upon x. Okay na? Right, substitute x is equal to 0. So, here 1 plus 0, 1 minus cube root of 1 plus 0 is also, generally we won't go for, these are all real numbers, x approaches to 0. Therefore, actually 1 plus 0 cube root of 1 means you will have 3 values out of 1 is a real number, remaining 2 are complex numbers. That's why. So, here 0, so here 1 minus 1, 0, 0 by 0, you will get 0 by 0 form. From this, you can do the L'Hospital rule. That's why. So, limit extends to 0 is equal to root x derivative 1 by 2 root x. Again 1 plus x derivative, it is a 1. So, that's why minus cube root of 1 plus x. That means 1 by 3, 1 plus x whole power 1 by 3 minus 1, that is equal to minus 2 by 3. Under divided by x is equal to 1. Okay na? So, wherever x is there, substitute 0. So, this is a 1 plus 3, this is a 1 by 2 minus, this is a 1 by 3. So, LCM is 6, 3 minus 2, 1. So, 1 by 6 is your answer. So, therefore, f of 0 value is 1 by 6. From this, what you can understand? So, he is asked to find out the function is continuous at x is equal to 0. When he is saying that function is continuous at x is equal to 0, you can get the immediate conclusion that limit extends to 0, f of x is equal to f of x. It is exist. So, here no need to find out left hand side limit, right hand side limit, directly you can do this problem. Okay na? I hope that you understand this solution. Let us go for next problem. Welcome to this third problem. If the function f is defined from r minus 0, that means set of real numbers except 0 to r, is given by f of x is equal to 1 upon x minus 2 upon e power 2x minus 1 is continuous at x is equal to 0, then the value of f of 0 is saying. So, he is saying one word, that is continuous at x is equal to 0. That means it is continuous x is equal to 0 means what? Limit x tends to 0, f of x is equal to f of 0. That means if you want to find out f of 0, it is enough if you find out limit x tends to 0, f of x. Okay, so let us find out limit x tends to 0, f of x is equal to limit x tends to 0. This is a 1 by x minus 2 times e power 2x minus 1. Generally students, they will do mistake here. Why? Because so they separate the limits for both the functions. As x tends to 0, 1 by x tends to infinity. As x tends to 0, 2 by e power 2x minus 1 also tends to 0. Why? Because here x is in the denominator. As denominator increases, total fraction approaches to 0. Therefore, infinity minus infinity, they will say 0. Therefore, f of 0 is equal to 0. They will declare. That is wrong answer. Why? Because infinity minus infinity means we cannot say that it is a infinity minus infinity is an indeterminate form. So, this infinity, both are different. Okay, now then how to do this problem? Then first of all, you combine this function, you make it into 1. Okay, now, so let us see this solution. Limit x tends to 0, x upon e power 2x minus 1. So, here e power 2x minus 1 minus 2x. Okay, now, right. So, this you can do L'Hospital rule also, but L'Hospital rule if you do, see here denominator, here x is there, e power 2x minus 1 is there, u into v apply, again you will get denominator 0. Next derivative, it will be opened. Okay, now, so that's why don't try to do this L'Hospital rule, it takes some time. So, better you go for expansion. We have the expansion e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial. So, do this expansion, limit x tends to 0, e power 2x, in place of x, 2x is there. Therefore, this is a 1 plus 2x by 1 factorial, 2x square by 2 factorial, it's so on. Again here, minus 1 is there, minus 2x there. In the denominator also, e power 2x expansion, that is a 1 plus 2x by 1 factorial, 2x square by 2 factorial plus so on minus 1. Yes, any more cancellations are there? Yes, cancellations are there. See here, plus 1 minus 1 will get cancelled, plus 2x by 1 factorial. 1 factorial means 1, that means plus 2x minus 2x is cancelled. So, here plus 1 minus 1 is not cancelled. Why? Because x into it is there. So, sorry, this is a under bracket only. Why? Because e power 2x minus 1. Right, you can cancel plus 1 minus 1. Okay. What are the ultimate remaining terms? Let us write it. So, this is a limit x tends to 0. So, here how much here? 2x whole square by 2 factorial. That is 2x whole square by 2 factorial plus 2x whole cube by 3 factorial plus so on it will come. Okay, now in the denominator x into here 2x by 1 factorial, next one 2x whole square by 2 factorial plus so on infinity. Then how to do this problem? The best thing is in the denominator, take x as common outside. Limit x tends to 0. This is a 4x square by 2 factorial, that means 2. This is a 8x cube by 6 plus so on. Denominator, I am taking x common outside. Already x is outside, x into x, x square. So, here 2 by 1 factorial plus 2 square 4 by 2, 2 into only 1x, so on infinity. So, here see here this x square is there though, divide with each term, you have to divide. So, then it will become limit x tends to 0, x square will cancel, 4 by 2 is equal to how much? 2 plus 8 by 6, that means 4 by 3 into x plus so on it will come. So, here also this x square will get cancelled, that is equal to 2 plus 2 into x something will go. Now, you see here wherever x is there substitute, from here every term will become 0, from second term onwards every term will become this. So, ultimately what remains here? 2 by 2. So that is equal to 1 will be your final answer. So dear student, this is one of the interesting problem. So it was given in, it is from Senge's textbook. Senge's problems I am discussing, right. So this is a very easy problem. So using expansion, the problem will become easy. Otherwise, you can do this L'Hospital rule also, you can do, no problem, okay. So I hope that you understand this solution. Let us go for next problem. Welcome to next problem. If f of x is equal to tan of pi by 4 plus log x to the base e whole to the power of log e to the base x. Here log x to the base e in the numerator, in the power log e to the base x is to be made continuous at x is equal to 1, then what is the value of 1, f of 1? What is the value of f of 1? Okay, now that means it is a made continuous at x is equal to 1. So we have to make them into x is equal to 1. That means it is a continuous at x is equal to 1. Therefore, we have limit extends to 1, f of x is equal to f of 1. If we want to find out f of 1, we have to find out limit extends to 1, f of x. Okay, right. So what is that? Limit extends to 1, f of x is equal to limit extends to 1. What is the f of x function? It is given as tan of pi by 4 plus log x to the base e whole to the power of log e to the base x. Then how to do this problem? Observe here, log x to the base e in the power log e to the base x is there. That means these two are reciprocals to each other. If its value is h, its value is 1 by h, 1 by h. That's why whenever log x to the base e, so wherever log x to the base e is there, substitute h. Yes, now coming to the limits also you have to change. As x tends to 1, x value tends to 1, that means log 1 to the base e, h value tends to 0. As x tends to 1, h value tends to 0. Try to understand this. So this is equal to limit h tends to 0 tan of pi by 4 plus h in the power 1 by h. So if it is log x to the base e is h, then log e to the base x value is 1 by h. As x value approaches to 1, h value approaches to 0. Right. Now wherever h is there, substitute here. Where if you substitute here tan pi by 4, that is 1 to the power of infinity. 1 to the power of infinity type of problem is there. So in the previous class I explained how to solve this. So total power you raise to e, that is equal to e to the power of limit h tends to 0. Whatever may be the base, you subtract 1, that is tan of pi by 4 plus h minus 1. Whatever may be in the power, that will become the coefficient, that is 1 by h. That's all. Then start the problem. So this is equal to e to the power of limit h tends to 0. So therefore tan of a plus b. So tan of a plus b means what? Tan a plus tan b by 1 minus tan a into tan b minus 1 into 1 by h. So tan a means tan pi by 4 value 1. Tan a plus tan b by 1 minus tan a into tan b minus 1. Now do this cross multiplication. So this is equal to e to the power of limit h tends to 0. So if you do this, plus 1 minus will cancel, minus tan is plus tan, hence to totally 2 tan h. 2 tan h by 1 minus tan h into 1 by h. 2 tan h by 1 minus tan h into h. Okay, now then this problem is becomes how to do this problem? E to the e power limit h tends to 0, 2 tan h by 1 minus tan h into 1 by h. Then how to proceed this problem? As h tends to 0, observe here, tan h by h value is equal to how much? 1. Limit h tends to 0, tan h by h value is 1, tan 0 value is 0. Okay. So once again I am telling. So here tan h by h value, as limit h tends to 0, tan h by h value is 1, Substitute tan h value, tan 0, 1 minus 0, 1. Therefore, ultimately you will get e square. So, e square is your perfect answer. Okay. So, from this problem, what you have to learn from this, 1 to the power of infinity solution you have to learn. Okay, now I hope that you understand this solution. Let us go for next problem. Let us welcome to this problem. So, f of x is equal to 1 plus modulus of sin x whole to the power of modulus of sin x, a by modulus of sin x. This function is defined between x lies between minus pi by 6 less than x less than 0, and at exactly 0 the function is defined as b. 0 less than x less than pi by 6, the function is defined as e power tan 2x upon tan 3x. Determine a and b so that the f of x is continuous at x is equal to 0. Continuous at x is equal to 0 means what? Limit x tends to 0, f of x is equal to f of 0. But observe here, this is a piecewise function. Piecewise function, so just so far we have discussed general functions, but this is a piecewise. Piecewise means what? From minus pi by 6 to 0, the function is defined like this. At exactly 0, the function is defined like this. From 0 to pi by 6, the function is defined like this. Okay. So, on the whole, the function from the domain is minus pi by 6 to plus pi by 6, open bracket. In this minus pi by 6 to plus pi by 6, the function is defined like that, piecewise. Then how to do this problem? Then we will take the left hand side limit and right hand side limit of this function. That means limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. We will take like that. See here, limit x tends to 0, f of x is equal to f of 0 means what? Since this is a piecewise function, so you have to take the left hand side limit and right hand side limit of 0. Okay, now see here. Now limit x tends to 0 means what? X less than 0. X less than 0, the function is defined like this. That is a limit x tends to 0, 1 plus modulus of sin x whole to the power of a by sin x is equal to limit x tends to 0 plus. So, 0 plus means what? So, here x greater than 0. 0 plus means x greater than 0 means this function you have to take. Limit x tends to 0 tan of 2x by e to the power of total e to the power of tan of 2x by tan 3x. That is equal to f of 0. F of 0 value is how much? It is given as b. Yes, almost the problem is over. See here, we have limit x tends to 0, 1 plus as x tends to 0, sin x is also tends to 0. That means 1 plus x into a to the power of 1 by sin x. Okay, now, so put sin x is equal to some a, as sin x as x tends to 0, sin x also tends to 0. Therefore, this value is given as e to the power of, see here, up to here 1 by, put it as whole to the power of a. So, here up to here whole to the power of a. Up to here limit x tends to 0, 1 plus x whole to the power of 1 by x is direct standard form is there, e to the power of a. Understand. Now, limit x tends to e to the power of tan 2x by tan 3x. So, you can apply the limit directly from here. Tan 2x by tan 3x means what? Tan 2x by x by tan 3x by x. So, divide with by x, you will get 2 by 3. So, that is equal to e to the power of 2 by 3. That is equal to how much? That is given as b value. That is given as b value. Understand this? Okay, now compare these two. E power a is equal to e power 2 by 3. Therefore, a is equal to 2 by 3. Compare this quantity, b is equal to e power 2 by 3. So, this is the answers for a value and b value. So, very, very easy problem. Here you have to, don't get panic by seeing this modulus of sin x, modulus of sin x. So, this is x whole to the power of 1 by x. Immediately you have to reciprocal sin x whole to the power of 1 by sin x. Up to here you will get e. This is total e power a. This is total e power 2 by 3 as extends to 0, e power 2 by 3, that's all. If you have an idea without using pen and paper also, you can solve this type of problems. Okay, na? I hope that you understand this solution. I hope that you enjoyed today's class, and in the tomorrow's class with some more problems and some more with a new topic, that is differentiability, I will come before you. Until then, all the best.